This video will be about the real-world specifications for the 8-gauge shotgun. If you're not aware of it, there are two main specifications. The original one that was used for an actual gun used for going hunting birds in mass. This gun that fired something had a bore diameter about the size of an American nickel, 80 plus caliber, was used to shoot birds. After a while it stopped being used and almost every fowling piece above a certain diameter was excluded. It is now considered a destructive device or a sporting use only for shooting targets or something like that device for very specific purposes. The other reason it can be used also as a destructive device is the fact that it's used to shoot metal slugs at cement and knock it loose when you're making cement. Called a kiln gun. The industrial caliber and the sporting caliber are related but not directly. A lot like the 4-gauge ended up just being used for flare cartridges and not fitting the standards. This has variations to it. Now, this is mostly based on people maybe being interested in cosplaying as the Halo character carrying around a Hippo 8-gauge Magnum shot shell-based M90 shotgun. It's a space gun. So, you might want to make this entirely out of plastic. You can also use aluminum and also real steel. Warning, make sure it can't actually fire anything. This also is enough information for you to be able to figure out whether or not you want to try to make a real 8-gauge. And again, depending on where you are, it may not be legal to do so, and it will never be a good idea. Now, I'm going to be invoking information about metal tubing diameters, mostly because that's what's available. Plastic tubing obviously is easier to mill, so let's worry about the worst case scenario, metal. This is for aluminum and steel, and also involving drill bits, and then you have to make your own chamber ream, or you don't and just make it look kind of cool by having all the rough-looking work done. First principles, we either start off with a barrel blank. This is a metal tube or pipe that you can find that is close to the correct diameters, slightly smaller than it should be for the inner diameter is usually preferable if you're making a real-world gun. Next, finding several pipe diameters that are close to each of the parts you need and then stacking them end to end and then somehow welding them or gluing them together with plastic and putting them inside of a sleeve to hide the work you've done. And the other one is to just rechamber the end of a barrel or blank or tight pipe or tube to be able to hold the shell. See also that you could just reimagine this using completely unrelated materials or just make up a shell from scratch. Warning, real shotgun shells can be made entirely out of plastic, so that's not going to be unauthentic at all. So here we go. Cartridge chamber specifications versus drill bit chambering sequence. Again, this is mostly oriented towards making a cosplay gun so you can dress up as a character from Halo. The bore diameter for these guns, depending on whether it's the industrial or non-industrial, is 0.819 inches or 0.835 inches. Basically 83.5 caliber all the way down to 82 almost. So let's look for those designs. Now the drill bit sequence here is going to sound stupid, but it has a reason for being there. 105 128ths. What does that work out to? 0.82 inches, almost exactly. That fits almost exactly the smallest bore diameter you're going to see. We're going to be doing something called a forcing cone. We're going to presume that you have either a 0.82 or a 0.835 barrel blank, and you need to be able to do the stages to make it to where when it's fired, it'll go into a smaller size. It's also helpful if you want to make sure that your Nerf dart goes through on a plastic one. Anyway, 105 128 inch drill bit will be 0.82. And we do that to a depth of 4.75 inches. And obviously, if it's already that diameter, you skip this step. Then we do 53/64. That works out to 0.828, or almost 0.83 exactly. And we do that to 4.5 inches depth. And then finally, we do to 4.25 inches. 107 128. That works out to 0.836 inches. That's slightly over the bore diameter of what you would have to have as the minimum bore diameter for the barrel. Now at that point, we're going to be drilling the chamber at 4 inches using another drill bit. Now, we have to discuss the shell diameters and differences and discrepancies again because there's two different versions of it. And also, there's dozens of different places posting information about this that may or not be correct. I'm using the entire range of minimum to maximum and trying to find something in the middle, something at maximum, and something at minimum. And in some cases, there's only one option, so we'll just use it. And it should be pointed out that this is all very much rounded off. The maximum length shell I could find was 4 inches. So we're going to drill for that first. Again, as we're doing this, this will actually either be too deep or not deep enough. Your mileage will vary. You have 2 ends of a barrel, drill one and then the other with a slightly different numbers, and you'll get one right. And the other end will just act as an area where it's been drilled and looks cool. Okay, here we go. The neck or mouth of the cartridge is 0.9114 or 0.914 inches in diameter. Now that looks like a typo. I'm not really sure if that's accurate, but let's go with it. Almost 91 caliber or 91.5. Now the only drill bit that comes close to it is 0.914 almost exactly. That screams at the top of its lungs that's probably the correct diameter. And that's a 117 128 drill bit. It's actually slightly larger than that by a tiny amount, but that's not relevant. We do that to the 4-inch max depth for the case. Yes, this isn't going to be accurate enough. You'll change it later, but these are the depths that will make it to where it'll probably chamber. The base diameter of these cartridges have variations to them, including the industrial one, which will come up a little while. 0.9252 or 0.93 base diameter. And if you were calling it a caliber, it'd be 92.5 or 93 caliber. Again, a narrow range, and we end up with only one drill bit. Then it's 0.929 and some change inches. That's close enough. We're going to use it. 119 128 for a drill bit. Now we do that to 2 inches or whatever, and we make it kind of a tapered shell with a step to it. Again, if you're making this as a mold to make plastic fake cartridges for your cosplay kit or whatever, this is what you would drill into the chunk of wood that you would then pour in your plastic and mash into place and make it into a shell. This would also be a good starting point for doing the reaming. I'll tell you how to do a chamber ream if we have time. Next, the rim diameter. This has to be inset in a barrel if it's a real one, most of the time, but not always. And in a really cool looking plastic one made out of PVC pipe, you'd probably want to do this. The rim diameter on these things, again, with variation, is 1.033 to 1.035. Again, a narrow range, but we don't end up with a convenient drill bit at all. Luckily, we don't have to. As long as it'll be larger than that, we're good. The drill bit size that I found is 1.063, much bigger than needed, but it's not a part even in a real gun where it would make any difference. It has to be about 3 millimeters deep, and we do that with a 27 millimeter drill bit. Now, by this point, you might have realized that I've created a bunch of discrepancies where it doesn't really match up with the depths I'm talking about, because then at the end of this, you have to trim the end of the barrel blank at the breech end clean. Again, there's 2 ends to your pipe. If you're doing this, I recommend doing it in PVC plastic tubing first. Practice. Find out how much of a pain in the rump it is to get this to even work at all, much less be straight and clean, and then do the other end. And start off with something more than 26 inches long, and then, again, try it with steel or aluminum or whatever. Now, would this be safe? We've removed a bunch of material from a metal tubing that could be as thin, very, very thin at this point, so we can outer sleeve this. Many of the barrel blank material, tubing, pipe, plastic, whatever, if you want to make it look impressive especially, will need around a 6-inch length of metal tubing or plastic or whatever on the outside to make it look reinforced or really reinforce it. You want to make it a few percentage points longer than the actual cartridge. That's why most guns, if you look at them, have a bulge right there where the cartridge is, because they thin out the barrel and then reinforce it in the design. And you can trim it down and make it look pretty if you like. Now, there is the problem, and it's the elephant in the room, or in this case, the hippo. Industrial cartridges include another diameter and another depth. Now, this is a 0.953 to 0.955 band around it, near the base, which makes it to where that's the base. This is the one quoted, I think, on Wikipedia most often. It corresponds very closely to a 0.953 drill bit. In fact, I think that's exactly what it is. And that's a 61/64. And it was done so that you could not put in industrial-grade, high-pressure cartridges into an old-style gun. It wouldn't fit. If you put the old-style standard shotgun shells into the industrial gun that's supposed to be smashing cement, it would go in, and you could even use them to do so, I guess. But the point is, it's either that, or if you happen to get these industrial cartridges, if you're going to fire them, or empty hulls you want to use for a cosplay item, you'll need to trim off that thing, or you're going to have to bore out your plastic barrel or your metal barrel with a 61/64 drill bit. And I'm very sure it's actually that drill bit diameter. Now, what pipe or tubing could you use to make this? Again, we can use aluminum, plastic, copper, brass, or real steel. Now, here are the diameters that come closest to it. The one that has the true bore or very close to the right bore. Again, if it's a shotgun, it just needs to be close. The actual bore diameter, again, is 0.835 exactly. At 0.834 inner diameter, we now have the most likely candidate. This is a number 14 gauge drawn over mandrel seamless tubing based piece of tubing. Its 1 inch outer diameter is a bit thin, but still maybe workable, and it has a 0.083 inch wall thickness. Now, obviously, if you're going to trim a chamber in it, you'd want to sleeve this, maybe. And again, there are plastic tubings that match this if you look on special order websites. Most of them were in Chinese or Japanese, so I can't read them, so I don't know. Now, another idea is to use one that's larger than you need for lower pressure and higher safety. And if you're going to replace a barrel on an old worn-out gun, number one, don't do it. But if you do, and you're just going to hang it on a wall, you might want to do this just in case somebody's stupid enough to chamber it. This one uses a 6 gauge thicker, 0.2 inch thick wall piece of tubing, seamless tubing, drawn over mandrel. It's overbore, and its 1.2 inches outer diameter makes it much better. But it won't contain the shot as well. You'll have lower performance. But again, if you want to make something as a replacement for a damaged gun, that would be safer. Now, the other end of the spectrum is about the dumbest idea possible, but I'll include it for discussion only. A 3/4 inch Schedule 40 standard black pipe made of steel, or a plastic tube if you want to do this. This is what I'm recommending for the cosplay version. Is 0.824 inner diameter. That's not the right diameter, but if it's shot, you can get away with it, and you might be able to do it. And it's 1.05 inches outer diameter, makes it in the range of being slightly less risky, but it is underbore and will cause a pressure spike. You'll need to do the forcing cone for a lot longer distance. I recommend starting at 6 inches. And again, sleeving the outside for reinforcement. Now, what about just starting off with something that has the right diameter for the shell, is very overbore, and you don't have to drill it? Okay, well, the base diameter on it, again, for the cartridge, was 0.93 biggest, and smallest was 0.914, let's say. Okay, well, let's look for barrel or pipe diameters that are like that. The one that comes closest to the smallest diameter is a number 19 gauge drawn over mandrel tubing pipe that's 1 inch outer diameter and 0.916 inner diameter. That's very close, and that would work if you find a cartridge that size. But most cartridges bell out, and they go up to 0.93. 0.93 inner diameter, 1 inch outer diameter, number 20 gauge, which is thinner, with a 0.035 wall will work, and that's another tubing type. Now, there are other variations that will be listed below if you want to look at them. You can also look up standard water pipe dimensions that are underbore, but only a little bit, at 0.92, a nice mid-range to make a chamber out of, and that's Schedule 5 stainless. Now, all of these can fit within an outer tube, and I'll just list them off quickly. Schedule 41 inch pipe has an inner diameter that's a little over an inch, and the extra space can be taken up by shimming it with steel sheeting or other material. And there's also an equivalent with drawn over mandrel tubing as well, with an inner diameter of 1.009, almost perfect for all purposes. Now for the cartridges. Again, just make some plastic toy ones, or even make real ones out of plastic. One of the metal tubing types, again, that's almost exactly the right bore diameter, 0.834, with a 1 inch outer diameter, can also work as a shell. You'd have to mill it down to fit into a chamber, but you could use that as a starting point to make a chamber. And if you're going to make real shells, you might end up welding them. And again, you can just make them out of plastic, but that's an option. A much more practical version is the Type M copper tubing that you can expand out from its normal 0.81 inner diameter and make it bigger and be a cartridge, or a starting point for a wall for one. And the 0.922 outer diameter electrical conduit that's used for carrying cabling that has a wall thickness that's very thin. It's called 3/4 inch electrical conduit, and it's called EMT. That would work very well and almost is exactly the right diameter, but would need to be pounded into a mast or shape to make it the right diameter and shape for making a cartridge out of. Again, repeating, this is mostly for people who want to make cosplay toys or something to hang on the wall, or maybe a prop for a movie. And yes, could be used, if you wanted to make a real barrel and real replacement if you do it carefully. practice, and then fire only when it works. Thanks for watching. Have a good day. Good luck.